All right, we're going to go ahead and get started. Welcome to our number 16th in a row. Welcome, come back. Thank you for coming back. This one is about transactional source data versus analytic data or analytical data. And the subtitle is Assembling Source Data to Train Intelligence. And I use the word assembling again to make sure that everybody really kind of gets their brain around what ultimately what we're really trying to do is assemble source data, assemble things as opposed to create things. You create one time, which is fine, but you want to take whatever you create for the benefit of efficiency and you want to put it into inventory so that you can assemble it later on. So I always use the word assembly as just kind of a mental reminder of what the efficient way to operate is. So want to thank again the IIBA of Tampa Bay as our partner on all of these meetups and these sessions. This particular one, this slide, many of you have seen many times, as a matter of fact, 16 times. I joke about, struggling with requirements and having all of these other groups that you're not alone. But I also want to take a moment and just touch on this and remind all the business analysts and product owners out there that we sometimes can get bogged down in trying to be experts in everything. And I've always tried to point out to people that really our expertise is really our ability to go find other subject matter experts. that we are the jack of all trades, master of none, middle person, liaison, however you want to title that role. And that while some of you are subject matter experts in a particular area, this isn't really that job where you're the expert. This is the job where you are a communicator. And again, all of these sessions really are about how do we communicate effectively with our stakeholders to elicit requirements effectively that are testable so we can build tested working solutions. So I always go back to that the purpose of what we do is to build tested working solutions through requirements. And requirements is hard. Those of you that do it on a daily basis know exactly what I'm talking about. I tend to, joke about, hey, if you have 25 or 50 stakeholders, each of whom has a different title and objective for the same project, what are the odds that you would make them all 100% happy? And the answer is very low. And therein lies the challenge of requirements, is that we have to convert natural language, which is ambiguous, into concrete testable statements that ultimately pass not only technology testing, but more importantly, user acceptance testing. And then that goes back to the, hey, if I got 50 stakeholders in my project, what are the odds I'm going to make them all 100% happy? So at the end of the day, this is a very challenging thing. If you're new to our session, my name is Richard Frederick. I teach I teach all kinds of classes, but I specialized in, I put together 2 specific classes on business data analytics, the language of data, which is really the underpinning or underlying structure of the digital transformation, which ultimately is about training intelligent assistants. Siri, Cortana, Hey Google, Bixby, whatever your favorite assistant turns out to be, Alexa, whatever that is. But the course itself that I teach, both courses are traditional. Requirements is a traditional course, elicit, analyze, document, and validate. Project management is a traditional course, initiate, plan, execute, control, and close. The difference is that as opposed to the exercises or the example being product or process, the examples that I use or focus on is data or digital transformation, business data analytics. So this is the agenda for the requirements class. This is the agenda for the project management class, and you'll notice that it's color-coded. As we go through the slides, you'll see that those colors are associated with photographs of the roles that are tied to them. So this is what I call the team of the future. I'll show you them in a moment, but you'll see that the Purple is, understanding the business need. Yellow is understanding the data. There's two greens. One is prepare the data. The other is model the data. And then evaluate the data is blue and deploy the solution is orange. Very brief about me and my background. I owned a software company in the 1990s. We specialized in software integration and workflow automation. We built something known as autonomous software robots. We call them Autobots just to help clients wrap their head around what we were doing. I did that 20-something years ago, thought for sure by the year 2005, everybody would be automated. I'm off probably by about 20 years. I'm now kind of guessing that 2025, I'm almost 100% certain will be the paradigm shift to intelligent assistants, very much like we shifted from the typewriter to email in the late 80s, early 90s. The big transition is going to be really the recognition that you have a new person on your team. So all of these sessions, we seek to understand, and that's kind of the goal of a business analyst. If you look to the right, you'll see photographs with colored borders. Those represent roles of the team of the future. Let me run down them very quickly. Purple represents your business analyst, product owner. The yellow outline is your scrum master, project manager, database administrator. I know that you're thinking, wait a second, those three don't really go together, but the DBA is how you're going to communicate effectively with your intelligence. Underneath that is my IT system architect. Underneath that in the green, the other green is the developer, data scientist, subject matter expert. Underneath that in the blue outline is my QA test. And then at the bottom in orange is my intelligent assistant. In this case, it's Cortana because that's the only one I have a photograph of. So this particular section about transactional data versus analytical data, we're going to cover just the concepts of what the differences are, what those two things are. Operational data versus data warehouse, transaction volumes versus historical reporting and analysis, and then talk about SQL data creation versus SQL data manipulation. So the reason I put this together was there's a tendency to think of data as one kind of data across everything. And really, that's not helpful a lot of times as a business analyst, because when you're talking to your stakeholders, sometimes they're talking about transactional data and sometimes they're talking about analytic data. And it helps to know in your mind, what the differences are. And again, for those of you that are literal, I'm going to be very general and almost hybrid in the way that I explain this, because I don't want, the idea was that you had some simple way that you could, as you're communicating with your stakeholder, you could hear them say some words that would help you think, okay, they're talking about transactional data, versus if they're speaking differently, they're talking about analytic data. Previously, we did a whole thing about data transformation, data behavior. This slide came up. I thought I could reuse it again here. I thought it was important to reuse it again here. And of course, I color coded these photographs on this slide that go back to that project management agenda. So as you're going through these slides, if you have that project management agenda in front of you, let's say you print it out, it's really useful because now you can see where all these pieces connect. So that's the idea behind color coding everything. But in this scenario, this is kind of the architecture of how we move data from transactional into analytic. And of course, I use the word assembly as opposed to the word transformation, because again, I want you to think in terms of the data's already been set up to be analyzed. Okay, and that's an important concept for us as analysts, is that if we're always in the process of creating something, we're not very efficient in the way that we operate. So the idea is to move from creation into assembly so that the entire process runs much faster. So based on that slide, I wanted to kind of go onto this next slide, and you'll still see the photographs. Instead of wrapping all the way around or across the top and down, what I did was I sort of tried to group them by the transactional side and the analytical side. And the transactional side, we're going to be talking about in detail, but I just wanted to point out a couple of different things. You know, obviously the business analyst, product owner, project manager, scrum master, and the IT system architect, they're going to be involved in all of it, but just for the sake of this presentation, I want you to think in terms of they're really the starting point for transactional data. They're the group that's going to be talking to the stakeholders about, you know, what kind of data, how do you want it structured initially. You'll notice the transactional, if you look down below, there's like a little factory icon, and then there's an image of an ERD, and then there's, looks like a little valve, and then there's a star schema, and then there's kind of a symbol for data warehouse. On the left-hand side, that transactional diagram, right underneath the word transactional, that ERD, that's usually in a traditional business analysis course. That's usually as far as we take people under the concept of data behavior. But that's really just the very beginning of ultimately where it has to go. So recognizing that a business analyst now is going to be on the front lines of training intelligent assistants, I always felt like it was really important for the analyst to understand the entire picture from both sides. Okay, so whether you're actively involved in that or not, you should at least be aware of that. So we're going to stay kind of down this left side, right side approach, even though in the real world it doesn't always work so cut and dry, just to make things simple for you when you're done to remember all of these pieces. So transactional data on the left side, and what I did on this slide is you'll see the photographs across the top, and then the images, the input and the outputs up down the side, and at the bottom, I took those images and I added two more pictures. The one on the left side obviously is a server room, which is, you know, the location of your transactional data. On the right side is kind of a network operations center, a NOC, or something of that format, where you actually see the outputs. So we're going to go from data ultimately to visual output. And once we get to visual output, that's when you know that your systems really are ready for intelligent assistance. It's taking that visual and taking it to the next step. That's really ultimately what we're trying to accomplish. So that just kind of shows you the journey all the way across. So what we want to do in this slide is we want to talk about just kind of generic differences. Transaction processing, online transaction processing, OLTP, is application oriented. So in a financial environment, we might be talking about loans, systems, or credit card systems, or savings systems, or trust. Those systems will hold very detailed data that are used to run the business. And generally speaking, that data is the most current up-to-date data, and it's isolated into unique relational databases, you know, first normal format, second, third normal format, etc. That data is also accessed repetitively throughout, you know, time, and it's usually associated with your kind of a clerical data entry or something of that nature. Whereas online analytical processing is more subject-oriented, customer, vendor, product activity, and it's a summarized data, and it's used to analyze your business. And rather than it being current, it's more like a snapshot of, hey, where are we at this moment in time? As opposed to being isolated, it's integrated, hence the star schema. That's the idea that you're going from an isolated ERD to an integrated star schema. As opposed to the repetitive access, generally speaking, it's ad hoc. But today, that's no longer the case because you have real-time dashboards that are showing data happening. But just kind of in your brain, giving you an idea of, okay, one is happening repetitively, one is happening when people are seeking answers. And under the online analytical processing, the consumer of that data generally is some sort of a knowledge user. It says manager, but really ultimately in the future, everybody's going to be a consumer of analytical data. That's really kind of an outcome of the digital transformation. Going back to the summary, the seek to understand, I pulled the contents of this presentation from this slide, and I thought, okay, this is a really good slide to just sort of talk about, you know, online transaction processing is normalized data where online analytical processing is denormalized data. And we did a whole presentation on what that means, so I'm not really going to cover that again. That was data transformation. You can go back and find that if you're interested. The source tends to be your daily transactions under online transaction processing. But for OLAP, your source is your online transaction processing. So you can't really jump. You have to go through your OLTP to get to OLAP. The OLAP data actually comes from your transaction data, your source data, okay? It says motive, faster insert, update, deletes, and improves data quality by reducing redundancy. One of the challenges of transactional data is getting the data clean. And that's really the role of your IT system architect. Again, we talked about that under data transformation, but understand that if you're doing a data project, that's going to be the bulk of the time spent, is making sure that the data is clean. And there's a lot of different ways to define what that means, but just kind of generically, that's where a lot of our time is spent. In order to do what? Have faster analysis. And, obviously it's a search by combining tables, which is a join command. So we're going to be talking about it here in a second. The transaction processing side, under SQL, it says, it's simple and medium complexity. Again, all of this is kind of debatable. I just thought, well, okay, as a way to make it simple, just to remember, yeah, it's more simple than possibly what you're ultimately trying to do with your analysis, which is much more complex because you're trying to include forecasting. And that's where we talked about project estimating, and we talked about Monte Carlo analysis, which is regression or a forecasting method. And later on, we're going to come back and discuss earned value, which is kind of the concept behind how you do forecasting. From a SQL perspective, these two groups, so again, going back to transactional data, we don't really teach business analysts how to connect ERDs to SQL. I don't know why. I try to tell them, but we don't usually bring it up. So I think it's really useful for a business analyst to understand that in SQL, there's a data creation language and a data manipulation language. And the data creation language is usually what's associated with your entity relationship diagram. And when you build out these data structures that are also called instances, you'll see it's the same. You got a data structure instance for both sides, whether it's transactional data or analytical data. But on SQL, you're using what's known as the data creation language for the ERD side of it. Generally, I mean, there's a lot of other commands, and obviously you can go back and forth, but generally speaking, you got your create table, your insert into, update your table, delete records, commit your changes, or roll back changes, things of that nature. On the analytical side is where you're starting to manipulate your data using the commands select from, or a join command, or different kinds of join commands. And then where is giving you attributes that you're looking for, or having as another set of attributes. And then grouping by these attributes or ordering by these attributes. All of that allows you to do what's called aggregation and summarization, which is what drives your dashboard. Okay, so as an analyst, this is really important, is that as you're sitting there and you're listening to your stakeholders communicate about what they want, you have to think in terms of SQL, because at some point SQL will be probably some part of your process. Now, I'm not telling you got to know SQL, but if you can learn it, it's going to benefit you. The more you learn about SQL, the better it's going to benefit you as it relates to data. Okay, and there's also NoSQL. That's another story, but which stands for not only SQL. but the main transactional stuff that you're still seeing in the broadest environment is SQL. So I know there's a lot of discussion about, well, one versus the other, but generally speaking, this is kind of going all over the place. All right, so this was sort of, I joked about, and I don't know if any of you saw it or not, but I joked about the idea of getting to see what a data structure instance looks like if written in structured English. And I do this exercise also in the requirements class, because a lot of times we see things on the right-hand side, that's the technical way you write it: order equals, order number plus, order date plus, and then you see, these brackets, and so there's brackets, and there's different kinds of brackets, and they actually have a meaning. So what I did was I took that data structure instance and I rewrote it in structured English. I'm not going to walk you through it. This is the kind of thing that I highly recommend that you get the PDF, print it out, and analyze it on your own. But understand that if you are building data solutions, you're going to want to know how to write data structures in structured English. And so I put this together as a tool to kind of help you, okay, here's how I would write this statement in structured English. And I think that that's a really useful tool to have at some point if you're trying to document data instances, data structure instances. All right. And then the last thing I wanted to do, again, because you're going to have data structure instances of both transactional data requirements as well as analytical data requirements. The last thing I want to do is show you, and this is another slide that comes from the requirements course. It's the data dictionary process specification form. And it's my opinion, just a humble opinion, that the business analyst, product owner, needs to be very knowledgeable about data dictionaries. I mean, it's really going to be ownership, in my opinion, of the Scrum Master, Project Manager, DBA. But I think that the business analyst, product owner should also be very aware of these from a elicitation standpoint. So again, the slide's kind of small and I apologize, and I won't go through this in any detail, but you should, if you get the chance, send me an email and I'll send you back the slide deck, and I highly recommend that you print this out and take a look at it. It's fascinating because for every process that is created, there should be a record of what that process formula is. So in this particular form, there's an input data flow, an output data flow, a type of a process, and then the process logic, which again is really useful if you're a business analyst to understand how all of these pieces are set up to drive data to the dashboard. Once we get data to the dashboard, then we're able to really apply predictive analytics, which is the ability to go to your intelligent assistant and query the assistant about the future, which absolutely is, to me, still mind-boggling. The idea would be like almost saying, hey, Cortana, hey Siri, hey Alexa, what's the winning lottery number for next week? It's kind of what you're asking for, but that's the vision. I don't know if any of you read this or not, but Amazon wants to have Alexa predict what you want before you ask for it. So this is the structure of how you get there. All of this information is the structure of how you get there. Okay, so that kind of wraps up this. So all of my courses, all of these sessions, and everything that I teach is open source. And I'm always trying to tell everybody who comes to my classes, it's train the trainer. And the idea is that you come and you learn something, and then you go teach it to somebody else. And the benefit of that, there's two benefits. Obviously, is you're sharing the knowledge, but more importantly, you're reaffirming what you learned in your head. And your ability to communicate it to somebody else is going to help you memorize it even better. So the more you get it and you share it, the stronger it grows in your head. So going back to what we just covered, transactional structures versus analytical structures. Again, the ERD versus the STAR schema. Operational data is your transactional data. Your analytic data is going to probably be stored in something known as a data warehouse. And those repositories are going to be used for ad hoc querying, which technically could be in real time. So again, we say ad hoc, but it can happen in real time. The goal or the motive behind the different environments, the transactional environment is really about volume. And we covered that with the 10 Ds of data, and volume was right up there in the very beginning. Value, volume was probably, I think, number 2. versus the ability to do historical reporting. And historical reporting is always based on actual data. And in order to forecast or predict the future, you've got to have actual data. So, and again, we're going to cover that in more detail when we talk about earned value EZ. And then complexity, and I don't know if complexity is the right word, but really what we want to say is that on the transactional side, you tend to hear more of data creation, SQL types of requirements. And on the analytics side, you tend to hear more about the data manipulation SQL requirement statements. For those of you that do not remember, early on in one of the earliest sessions, we did a whole thing about structured English and structured query language. So if you're new to this and you want, you can go back through our meetups or LinkedIn sessions, and we posted videos. I think I've got most of them out there, but eventually I'll have them all the way back to the very beginning so that you can go back through and just look through either the LinkedIn sessions on our LinkedIn meetup group, or on our LinkedIn group or the meetup group. You can go all the way back and hopefully find the videos. Actually, I know on meetup they're all the way back to the beginning. I don't have them all the way back to the beginning on LinkedIn yet, but I'm working on that. Finally, if you are new to this, please join our group. It's free. That's what I love about it. It doesn't cost anything. If you would like a hard copy of this slide deck, just please send me an email, rfrederick.pmp@gmail.com, and just say, hey, I'd like a hard copy of the presentation. I already know which group you're in. Again, please join our meetup group if you think this is a good use of time. We're going to do this every Friday. Next week, we're taking off because of the holiday, but we'll be resuming right after that. If you are not connected to me, I'd really be honored to join your network. So you can reach out to me at linkedin.com at rfrederick. And if you are interested in learning more about the classes that I teach, I'd love to schedule a meeting with you. That's meetings.hubspot.com, rfrederick-pmp. All right. Any questions? Anybody got any questions? That was fast, right? That was a good one. Just a note, Cliff has put up information in the text chat, again, about how you can join us. Please feel free to join us. We have a large group. We're very active. As you can see, we do this every week. So that's it. We are done. Thank you again for your time. Yes, everyone have a wonderful Thanksgiving.
Have a good time up, Richard. See you in a couple of weeks.
Okay, great.